All right, I hope this records properly. So first off, I need to give credit where credit is always due. All these professors have taught me how to become good at this. We're moving. I hope it shows the image. Okay, I'm gonna wait a few seconds for the recording to catch up. So yes. So I give credit to all these people, and and then these are the ones that made me good at this. So here you go. And most of this content is made by Dr. Sanchez. Over here we'll start with this one. Yeah, because it just shows something incredible in my opinion. So we'll talk about this one first. Another thing I will mention is I will be leaving quickly because I need to finish up my homework. I will sometimes I don't go to office hours if I didn't finish my homework. So I need to finish my homework before I go to the other office hours, which I actually had to skip one because I didn't finish my homework in time. So I mean, by finish I mean start doing it to a point that you don't understand how to continue. Yeah. Anyways, that's not important here. Anyway, so first of all, I need to talk about this stuff right here but it'll be short because I have other things to do, is what I'm trying to say. This video won't be long. So we start with this kind of uniform thing, but to the curious part over here, the non-intuitive part, is why is this going upwards? And that's because we're going to supersonic. That's literally all you need to know. This thing is supersonic, therefore you can't assume this kind of relationship. In a subsonic area, we always assume this, right? That's our intuitive process, but it goes up instead. Now, clearly, I need to show the math on some of the stuff, and I'm thinking of doing the math for this over here. So this over here is an illustration of this kind of curve. Now, do I know what the goes plus tan with the angle x 1 minus x divided by c? That is a factor that was developed by it's given basically is what I'm trying to say, but I don't know. I'm trying to use fancy words and it doesn't really come back. I'm trying to express. Oh yeah, I know why I'm trying to say x divided by c is what I'm trying to say. X divided by c is such a is a way to express a form that indicates that well, I'm trying to say that in aerodynamics that's common, but I don't know how to express that correctly, so I'm fumbling with my words. So I'm just going to say this. It's very common in aerospace to see x divided by c, and you get comfortable with it. So, okay. Next part I need to express is what is n? N is the normal of this stuff, right? It's just the normal, and it's going to be outwardly projected. Yeah. So what does that really indicate? Well, if I have an n over here, right? Over here, you have something like this and something like this, right? So this over here is considered ny. I believe this is considered no, this is right? Nx, yes. And how you define that is through, I believe, what we call an angle. And this goes to really aerodynamics, if I remember correctly. So you need to know convention. If I remember correctly, convention is ds, right? And then over here is, I believe, the angle. The angle goes over here, data. I believe that's it. And oh yeah, they do say that. Yeah, data is what they say. But the question is, first off, how do I know theta angle and this is the same thing? Now, how I know that is because this is y, right? Now, let me ask you, what is tan of theta, right? If you think about it, that is y over x, right? Y over x, right? Yeah. Can you now see that this delta y over delta x is kind of like dy dx? So this is kind of geometrically showcasing y is tan x over here, plus or minus. Um, and that showcases how this equation over here operates and you can get an angle from it. That's how I have looked at it. It's a one way to look at it. I would say there's a better way because I know there's a better way. Um, but I need to look at my aerodynamics note with Dr. Schmidt's notes, which I left at my real home. So the explanation is gonna have to do. Yes. Yes. Okay. But this explanation is perfectly valid, I believe. There's no illogical steps I have taken yet. I think. I personally think there's no illogical steps, but you could think differently. Now, the second thing is what we need to define as ds. ds over here, if you look over here, is kind of saying line like this. So over here you have the x over here, which is dx. Now dx, okay, so what that tells you is that we can get dx, right? This slope over here is ds, right? I believe there's multiple ways to show it. I'm trying to play with the geometry to figure it out. But give me a second. So if you think about it, let me just show you this. What we have is basically the theta angle like this, right? And this over here is the square root of which is ds. Let's just say that's ds. You have an angle like this, and then you try to get the arc length. This is the arc length. And what we have learned, another way to write arc length is basically using what we call, because it's a very thin angle. You can use dx, and then we can say cosine of this, right? And then Let me just say cosine. So this works. So this is valid over here. So far, what we have validated is these two conditions. Okay. Now we know this is true no matter what. Yeah. We know this is true. We know this is true. Okay, so we're not doing any viscous term, which is okay. And then we know tan theta is geometrically the same as this one because I see what I see what you mean. Yes, because you have theta over here as the regular theta, and then you have the distribution change from later on what's happening as we move on from the system. So what's happening here, if I can explain it, is that from this kind of thing, we know the initial angle is alpha. And this section over here is getting the angle over here, basically, and so forth. And so it's just propagating downwards over here. And I'm assuming because it's symmetric, you only need to do one side, and then you can get the other one, is what think he's trying to get, maybe. So you can get the pressure, and in reality, the pressure over here and the pressure over here should turn the same way eventually. And then he does an integral over here. Now, yes, that's beautiful. Oh, that's actually pretty beautiful. But I need to print out the chart definitely because I'm not doing that by hand. It's a beautiful equation, I must admit. Okay, I'm gonna stop the recording here, and I told you it's gonna be short. I'm not editing this too much either, so it's gonna be kind of shitty video, but I have things to do.